paste it here. Hey, and here we are. Isn't the copy paste function is just so freaking good? It is so good. It is better than so many things in life. 6:08 a.m. I'm a little bit tired. Today was hard to wake up. There's days like this where it's just hard. There's days where it's hard, and today is one of them. Alright, let's take out our lamp. Where do we put our lamp at? It's right there. We still have 2 bars. Where do we want this lamp? Over. Hold on a second. Hold on a second. Extra privacy. We like privacy. Wasn't it be better over here, the lamp? And it's paler than that. We should lower the kelvins. No, increase the kelvins. That's better. That's more fitting. There's a lot of theory here in light, folks. It's not as straightforward as it might seem. Lighting. Lighting is a pretty complex topic. Nice, stream elements is here. Salut, salut Natir. Oh madame, oh là là. Pourquoi madame? C'est quoi ça Natir? You like to speak French to me, huh? You like it. Alright. Natir, how are you today? How's everything in? Alright, I know you're originally from Ethiopia, but right now I think you live in the United States. I forgot where though. How are things in the United States? Tell me. Or maybe Canada. I was thinking Canada as well. So how are things in Canada? Tell me about them. Now let's go quickly on Discord and check out what we said we were going to do. Discord. I was trying to learn, then I stopped. French? It's always a good idea to stop learning French. It's too complicated, man. Stop, just stop. Don't do it. French is too complicated. Alright. I did something on OBS and now OBS is upset that I did that. Ay ay ay. Yeah, whatever. Kenya, Canada, and Canada is fine. Canada's fine. Nice. Canada is fine. That's what we like. French isn't complicated. You don't think so? Man, that you didn't learn French enough. French is complicated. French is like these exceptions everywhere. French is French was made difficult on purpose by King Louis XIV in order to be able to distinguish the rich from the poor, the educated from the uneducated, and therefore includes many rules, many things that are confusing, just to show whether how educated you were. 1/3 of English is French. No, I agree. There's a few words that go together. All right, so there's a few words that go together. In this sentence, there's absolutely nothing that's similar to French. In this sentence, hold on, that's wrong. Some nouns are close to French, but in general, they're not really similar. Yeah, look at that. We're already 47 on the Discord. That's pretty cool. And thank you, Natir, for making it a little bit more entertaining lately. Just answering someone real quick on Discord. PD. Alright, and I'm going to check out real quick the plan that we had for Tuesday. Tuesday we have our networking. I don't like much working with protocol, stuff like this. I've taken notes on them. It's actually to make sense of it. Not just learn by heart. Where's my notebook at? English breaks down 25% French, 28.24 Latin, and 25% Germanic. And there's some Greek as well. Yeah? Isn't there as well some Celtic? There's some Greek. French? Maybe. Look, let's look at your sentence. English breaks down 25% French, 28% Latin, and some Greek. You see, English in French is anglais. Breaks down is not in French. There's quite a few French words in there, ultimately. Now, I'm going to get my notebook notes here. I'll be right back. Vocabulary. I think nouns are quite similar. Nouns are quite similar. You can guess some things, like a lot of political stuff, a lot of science stuff are together, the words. But if you want to talk just normal conversation, it's not that easy. It's not that easy. My partner, for instance, speaks English, Polish, Spanish fluently, but she still struggles with French. Like, because French is also a big part of Spanish, but yet it's not that easy for her. There's a lot of pronunciation that's unique in French. Like the sound that's not something that many people can pronounce. I'll be right there. Let's hear. Vocabulary says it's here. Oof. One of these days I should do a stream in French. Just pure French for zero reason. For absolutely zero reason. Alright, here we go. Today we're talking about networking, folks. We're talking about networking. Samantha is also here. Hello. Also, Butch Lurk. Ooh. Nice. Samantha's here, just lurking. Hey, Samantha. Let's go in overall chill. Alright, great. The camera's not here. Let's copy the camera. We could have a little bit of music today. We can have a little bit of music. Just because we gotta chill ourselves from that network thing. Spotify. Oh, don't look at my Spotify. No, you can't. Are you folks kind of I feel like I'm a little bit insecure about my Spotify. Not sure why. Insecure? Not insecure. Insecure about my Spotify. There's something strange about it. It's like I don't like people seeing what I like in terms of songs. It feels, I don't know. It feels too personal to be shareable. Nice. A little too loud, I think. The problem with some words are like bicycle used to be bicyclette mostly, and now it's mainly vélo. Yeah, it's just one example. You know, there's some things that are the other way around. Like in Spanish, or in French, do you know the word in French for car? Why did I want to check? I want to check something on my phone real quick. No idea. I guess I'll let it go. the word in French for car, do you know it? It's here. Yes, one sec, it's A. Yeah, go for it, take your time. I used to. Do you want the first letter? What did I want to do? I wanted to check this thing. Alright, let me show you real quick in my notes. So I'm following a course on for the CISSP, and there's the following thing that's been popping up. It says this routing. Wait, can you see it? Is it reversed? Let me reverse it. It's this thing called. I really write poorly, huh? But here you can maybe see it. It says routing protocols, and there's this whole diagram that I got from it in ChatGPT. Let's face it, and it tells me what to do. It tells me like what are different things, and honestly, I understand absolutely zero things about it. I think it's pretty cool because it's all about routing, and I don't know anything about it. I'm not even sure what AS means here. So yeah, let's get to know all these things. Let's spend some time trying to know all these things. That's it. Are you on the first letter? It is a V. It is a V, and there's not too many words in French that start with a V. Nice. So routing protocols, there's two types. There's IGP protocols. IGP protocols. An interior gateway protocol is a type of routing protocol used to share information between routers with a single administrative network. So apparently there's two types. There's IGP protocols and EGP protocols. Okay, so there's two types. Yeah, it makes sense that they're mutually exclusive. Ah, you got it. Voiture. So yeah, voiture in French is the new word as well. In Spanish they use the in Spanish they use the you looked it up. In Spanish they use the old way of saying, which is coche, which is back in the time where there was the carriage carried by a horse. They stick with the same thing. Actually, we did too. Cush. Never mind. This is bullshit. Cush. Voiture. A horse carriage. I don't know. Something happened. I'm not sure there what happened. Never mind. My story's bad. Please just disconnect from this stream. It's awful. Alright, so we have two types of network protocols. We have the IGP, interior gateway protocols. Okay. So let's take a note on this. What the heck could the interior gateway protocol be like? Nitzir, do you know how good are you at networking? Interior gateway protocol. And here's exterior. What could this mean, the fact that there's interior and exterior? Exterior gateway. So, I want to actually get something pretty good. Baldung. Let's go check them out. Oh, you can't see my screen. There we go. Routing, IGP and EGP protocols. Introduction. Nowadays, the internet is a rich environment that provides several services and resources. However, the internet has grown. It has become more complex and hard to manage. Yeah, makes sense. In this way, network communications now require complex strategies of path selections and several network functions processing to enable network traffic from the source to reach its destination. In particular, routers executing routing protocols are crucial elements in this process. There are two categories of routing protocols: interior gateway protocols and external gateway protocols. In this tutorial, we'll explore both IGP and EGP. Initially, we'll review routing and understand what autonomous systems are in the context of networking. Thus, we'll in-depth study IGP and EGP. It's not very English there. Finally, we'll compare these routing protocol categories in a systematic summary. Okay, that's pretty cool. So routing. I actually don't know what routing is. Every time I have to make it up that I know. Routing is layer 3 of the OSI model, no? That I know. In short, the routing process means moving data from an origin point, the source, to another, the destination. In the internet scenario, this process interconnects different networks and is performed by routers. Routing relies on protocols that enable routers to identify the source and destination points. These protocols provide addresses that uniquely identify a particular network. Hello, everyone. Hello. Who is it? BlazeBits. Thank you very much, and welcome all 29 viewers. Thank you very much, BlazeBits, for the raid. Hey, everyone. We're focusing right now. There we go, hacking the planet. I was like, whoa, is no one hacking the planet here? Nice. BlazeBits saying hack the planet. Hey everyone, teach us how to hack. Yeah, sounds good. Bandit. I like that name, Bandit. That's pretty creative. Teach us how to hack. That sounds good, but sounds good. Let's do it. So today, folks, we are studying networks. And hacking, when you think about hacking, what is it really like? It is about getting into stuff and staying there and extracting things you should not extract, right? It's about having actually, how do you define hacking? It's about using unconventional ways to get through what you want to get, no? It's about being creative. It's about using the unexpected. Creative abuse of admin tools. I like that. So, in order to creatively abuse admin tools, we have to understand admin tools. And one thing I'm not good at is networking. I'm really not good at that. So, it is a great time to learn all of us together about the different things in networking. Now, this is done in the context of me studying for the CISSP, but it can definitely be done for the context of hacking as well. Just let me show you one thing real quick. I'm going to show you my notes and show you what we're going to focus on today. I got these notes from my course I've been taking. It's so we got routing protocols here at the top, and there's two types of protocols here: interior gateway protocol and exterior gateway protocol. Do you folks know about those? Do these make sense to you? And then we have within the IGP protocols, we have distance vectors, link state, and then a bunch of stuff here that I don't understand. RIP, which I don't think means rest in peace. We have a bunch of stuff here that we need to understand in order to, one, pass the CISSP, and two, hack like legends. Because if you don't know networking, whether you're doing IT or cybersecurity or hacking, you're kind of screwed. Corrupting the memories. Now, Bandit, I will say that this is one way of doing it. It's not what hacking is about. So yeah, folks, that's what we're doing today. We have another hour and a half in front of us. So yeah, take a sip of water. I don't have water, but you should have some. Take a sip of something that you like to drink. And yeah, let's get started. So we're learning about here the difference between IGP and EGP, which I don't know much about. I don't know much about it. Alright, so we have a routing. Routing, I don't know much apart from the fact that there's routers out there. I think they're level 3 OSI model routers, and they connect through IP addresses to the internet. That's right about what I know. All right, an example of these the protocols is, okay, let's start again. In short, the routing process means moving data from an origin point, the source, to another one, the destination. Sounds pretty straightforward. In the internet scenario, this process interconnects different networks and is performed by routers. Makes sense. Routing relies on protocols that enable routers to identify the source and destination points. These protocols provide addresses that uniquely identify a particular networked entity in a network. For example, these protocols is the Internet Protocol. Makes sense, no? However, routers must decide which path to use among these available ones for forwarding data in order to achieve the proper destination. A router takes its destination based on routing protocols. This is what routing protocols are. So folks, whenever what's it called? A router gets a package and is like, oh, send this to this IP address. It has routing protocols in it. It's the routing protocols that decide where it's about to be sent. That's it. So routing protocols are basically the highway system of computing. You and I are seeing me. You and I are connecting with each other thanks to routing protocols. Because somewhere on your computer, your computer connected to a router, which knew how to get to me, and my router knew how to get to you. And that's why we're connected. Insane. Insane. Alright, so this is what routing protocols are for. I'm going to take a note on this. They are for choosing the right path among to get to destination. Super simple, no? The idea is that all you need is to choose the right path and get to the right destination. That's quite simple, but let's see how it works in practice. And now there's two categories. It starts to make more sense. Internal Gateway Protocol. My guess is that they're the protocols that are used before. These protocols are used before the protocol. Before the server reaches the gateway, and then there's afterwards, which is EGP, which is exterior gateway. So it's after the gateway. So that's what it's about, I think, huh? Distance vector and links. We have a lot more to understand, folks. We can divide these protocols into two categories, internal and external. In these categories, in turn, indicate scenarios for using particular protocols according to the position of the source and destination entity in terms of networked autonomous systems. So, before studying what IGP and EGP are, we should have a clear understanding of what an autonomous system is in a network. We'll investigate this concept in the following section. Folks, do you all know what an autonomous system is? I have an idea. It's something that takes decisions automatically. But beyond that, I don't really know. Because everything is autonomous, no? What does autonomy mean? I feel like we're bordering a bit the topic of philosophy. Oh, you're not seeing my screen. I feel like you're all fell asleep now. Happens. Alright, autonomous systems. So in the network scenario, an autonomous system means a network, represented by a group of IP addresses, under the control of the same organization or group of operations. One more time. In the network scenarios, an autonomous systems means a network represented by a group of IP addresses under the control of the same organization or group of operators, with a single clearly defined routing policy enforced. Hey, me like Brendan Piano. You have a question. Sounds good. Me like Brendan Piano. I'll call you Brendan. Or Piano? I like Piano too. Oh. So many cool names to pick from your name. For different internet providers, ISPs, to identify and communicate with each other, they need exclusive autonomous system number provider provided by Internet Assigned Number Authority, IANA. Yeah, IGP Inside Gateway. I'm not sure, where did you get this? You're asking about something, but I don't know what this is. Photo menu size at media screen. White House. Hehe. White House footer. WP footer. Alright, yeah. Oh, okay. Epistemic Anarchist said something as well. Yeah, IGP inside gateway, but the gateway to the internet is not the gateway you configure on a PC. The PC gateway will generally be an internal router running an IGP. Huh. You know, I didn't know we had a gateway in our PC. But do PCs have gateways? Because I don't know if they communicate through layer 3 epistemic, no? Isn't the third layer done by the router instead of the PC? And if so, why do we need a gateway for this? What is this? E-columns FR with footer. I don't know what this is. You tell me. White House. WordPress CSS snippet. Yeah, that sounds pretty accurate. Whitehouse.gov. Ah, so you copied the WordPress. Whitehouse.gov. What is this, bro? I don't know. Donald Trump. Okay. Alright, Piano. Piano's coming back drunk from a party. Alright. So for different internet service providers to identify and communicate with each other, they need exclusive autonomous system numbers provided by the Internet Assigned Number Authority. These autonomous internet system numbers are extensively employed, for example, by Border Gateway Protocol. That correlates them with specific routing routes, thus being able to successfully steer network traffic between source and destinations that do not belong to the same autonomous system. Are extensively employed by example. Okay, these autonomous systems. The following figure depicts simple example of 4 autonomous systems with their respective number on the internet. I kind of get it what's happening, but not really as well. No, dude, Piano, let it go. I don't know what you're trying to say. Just talk about regular cybersecurity stuff, man. We don't need to know the Donald Trump or White House. We're here to hack. Tell us hacking related things. Yeah, a gateway is a default route on your PC. If the destination isn't on the LAN segment, one of your NICs, network internet component, you send to gateway. Okay. Yeah, it's off topic. Keep it related to subject matter, please. Nice. We got the double enforcement. Cyberpunk Reno. Adding a layer. Appreciate it, Cyberpunk Reno. Epistemic Anarchist. The L2, L3 Ethernet frames / IP packets things come in because you can directly reach things on your LAN segment with L2 only. You can reach directly things with the L2 only, I agree. So the L3, so I'm glad we got this right, because send the L3, layer 3 in the protocol, the OSI model, folks. It's if you don't know the OSI model, it's basically a model that goes between layer 1 to 7, with 1 being, we're just going to talk about the first 4. The one is first is physical, number 2 is data link, number 3 is network. This is where we're focusing on right now. And 4th is transport. Now the network layer is where we have the IP address. If you ever heard of IP address, it's coming from there. From the third layer. And in that layer is where we need to communicate with things that are outside of our own network. That's all there is to it for now, I think. I'm a little confused there, but I think this is where we're heading. Any network working scenario, an autonomous system means a network represented by a group of IP addresses. Okay, we're actually going to look at this. Now, folks, this is pretty hard to look at when we have the dark reader on, so forgive me, but it will have to be a little bit bright for a second. Or maybe we can actually just find the middle ground. Brightness. Okay, we can increase brightness. That's better, without having to put white. I think it's a nice middle ground. Can you see? Kind of. So here, I'm going to tell you about it anyway. Here we have AS 100. What is AS? Availability stuff? What is AS here, folks? Do you know what AS is? I don't know what to say, Cyberpunk Reno. Cyberpunk Reno asks 9 times out of 10, the gateway is the router, no? And then the gateway from LAN to the WAN, yes. I believe so. I would say yes. Oh, autonomous systems, of course. Thank you. Makes sense. A simple example of 4 autonomous systems with their respective number on the internet. Alright, I'm going to write this down because I have AS here in my notes, but I don't know what it means. So I'm going to write autonomous systems. Systems. Excuse me. Yeah, gateway is the router. I believe these might be different internet providers as well, because we talked about autonomous systems where provide the internet authority. So these might be just internet providers being massive. AS 100. Connect to different gateways. Here they have 2 gateways. So for instance, if my internet provider is I don't know, Orange or whatever, T-Mobile, maybe it's easier. It's T-Mobile, and I want to connect to someone else within T-Mobile, it's possible that it doesn't require this, right? It's just going to go IP to IP. Kind of like here, AS 350, it's going to go between here and here. It's not going to go outside of it. Yeah, okay, so yeah, that applies to a SOHO, but at an enterprise level, a layer 3 switch could be the gateway for the VLANs within the internal network. For SOHO, but at an enterprise level, a layer 3 switch could be the gateway for the VLANs within the internal network. Yeah, I think so. I think so. When your company network is large enough, I think it makes sense to have some kind of layer 3 routing. No? What do you folks think? Epistemic. What's your take on this? So SOHO is equals to small office, home office. Yeah, enterprise level, I think you do, because you're gonna have different kind of networks, right? If you're probably gonna have 2 locations. You may even have different floors, and I think for this you're gonna need different IP routings. I don't know. Kind of guessing on everything I know, but I'm not sure about this full instant. Alright, notably, as the networks get popular and internet grows, the complexity of managing increasing number of autonomous systems also grows, so routing network traffic over the internet becomes more challenging daily. Yeah, no shit. In this context, the IGP and EGP protocols emerge to tackle particular challenges of the routing tasks. These protocols enable network entities to communicate internally and externally to the autonomous systems they belong to. Okay, so the protocols... I think that's what it is, folks. The IGP is to communicate within your network, and the EGP is to communicate with other ones. We'll have details about IGP and EGP and how they correlate with autonomous systems in the following section. You know what, I'm going to ask for confirmation from ChatGPT. I don't know about this. I don't understand the idea of autonomous systems. Autonomous systems. So let me give my assistant real quick to deep dive on this. Oh man. Oof. Alright, let's see. Recent chords, Vibe Watches, OSI model. Oh. I'm gonna pick up the chat from yesterday. Alright, here we go. Let's start from here. I don't understand the concept of autonomous systems. L3 switch basically just means a switch with a router built in it, and yeah, common in enterprises with larger devices. Just means a switch with a router built in it. Yeah. Well, usually it's both, right? Usually it's both, but a router doesn't have to be a switch as well, but usually it is. I think. This is what I heard. Alright. Here the terminology may sound more complicated than it is. The key is autonomous system does not mean a network that operates itself. It is a confusing part. In internet routing, an autonomous system is basically a collection of networks that are controlled by one organization and follow one overall routing policy. Think of it as a networking kingdom. Oh, I love this idea. A networking kingdom. You get to elect a king and then chop its head off when things go wrong. The French in me is loving this. Imagine the internet as countries. Suppose we have AS100, ACME Corporation. They have a New York, London, and Tokyo. Okay. And they have a BGP, which is a Border Gateway Protocol, as we heard. And then AS200, which is the ISP, BG, AS100, another ISP. Each AS is controlled by a particular organization. So large corporations usually have their autonomous system, and so do ISPs. Each organization gets an autonomous system number, ASN. So let's write this down. It's a switch that can also do routing protocols, but they function largely independently. You aren't generally making switching decisions based on L3. Yeah, it makes sense. I think it makes sense for the most part. Let's check out what, let's make a definition of autonomous system. Just gonna check. Here's the most important part. Routers don't normally think about individual computers on the internet. Suppose your computer wants to reach a server at Google. Your traffic might conceptually travel from your computer into your ISP, into another ISP, into Google, into the Google server. That makes sense, no? BGP is largely concerned with which AS should I send this traffic toward, rather than which individual Google server should I use. Once the traffic gets inside Google's AS, Google's internal routing protocol takes over. Hold on, move to the next song. This is trash. Nice. Once the traffic gets inside Google AS, which is autonomous system, Google's internal routing protocol takes over. This is where IGP comes in. Got it. Got it. Okay. So an autonomous system is basically a super large network, right? Autonomous system is equal to a large networking environment owned by large corporations and ISPs. They are... So yeah, this is why we rely on internet providers, right? Because, like, in order to access something, because they're the ones that have the ASN. Without it, we wouldn't be able to get internet, no? We'd just be kind of stuck on our own network. So internet providers are the ones that have this number and the capability to communicate with other numbers. This is why we can't have internet without internet providers, without piggybacking off someone else's network. They are given an ASN. AS number. Not really defined by size, but yeah. Not really defined by size, okay. That means that you don't have to you can be small and still have an autonomous system for yourself. Imagine AS as a city. Inside this city is IGP. The city has its own road system. I think so far we understand this. The organization running 100 you're running AS 100 decides we'll use OSFP. Excuse me, OSPF. So this is one of the protocols here. Let's figure out how to get from A to F. This is all things these are all things that allow you to communicate inside. And now between cities there's BGP, which is between large networks. Okay, let's read this real quick, and as a third one, there's Border Gateway Protocol. So this is to communicate with the large, between large ASs. Allows communication between large ASs. Well, I don't think, not necessarily large. I can remove large, because ASs are large by definition. I think, no. In an internal network, the fundamental unit is a network segment. A router deals with the 92.68.0.0/24 segment, and the IGPs tells it how to reach, e.g. 168.1.24. Yeah, I get that. Yeah, makes sense. IGP is basically how to work within that internal network is a fundamental. Actually, I don't necessarily get it. On the internet, that unit is the AS. A router might be dealing with AS 3000 and e.g. tell it how to reach AS 4000. Yeah. So EGP is not something that most people deal with, no? Because it's really a thing that is used by internet providers, large companies and stuff like this. What is the criteria for becoming an AS owner? Let me pick up some tissues. I'll be right back. All right. No, you don't need if you have the no. You need it if you have to manage the public IPs to advertise the IPs you provide. It's like, hey folks, I own these IPs, this list of IPs. Make sure that you route these to me if they are within my range or they are within my list. You need to do it. You need it if you have to manage public IPs. To advertise the IPs you provide. When you use a typical ISP, they manage the public IP for you, so no, you don't need an AS. Okay, all right. This is a good question because owning an AS sounds like you need to be a giant ISP. You don't. The important distinction is between having an autonomous system number, ASN, and actually operating an AS on the internet. Okay. The basic requirement. An AS is justified when you have a distinct external routing policy. In other words, you need to make your own routing decisions that are different from simply following your upstream provider. Okay. Imagine a company called ACME. ACME AS. ISP number 1, ISP number 2 is internet. Okay. Got it. So maybe if you have two locations, on one side you use T-Mobile, on the other one you use, what's another one? Verizon. AMCE is multi-homed. It has connectivity through two different providers. AMCE might say, I want traffic to enter through ISP 1, but if ISP 1 fails, you as ISP number 2. And ACME can advertise its routes to both providers using BGP. It's a legitimate reason to have its own AS. In the RIPE region, the traditional current rule is quite explicit. RIPE says a network must be multi-homed to qualify for ASN, and it must have a unique routing policy. One ASP, one network, and one ASN because it's cool. Generally, no. Two ASPs plus independent routing, in this case, yes. Okay, so this is why you said epistemic, that you don't need to be large in order to have an ASN. So let's read a few more messages from epistemic here, the last few ones. No, you need it if you have to manage public IPs, to advertise the IPs you provide. When you use a typical ISP, they manage the public IP for you, so you don't need an AS. Exactly. To manage public IPs and to define trust relationship there, you have to configure to manage public IPs and to define the trust relationship there. You have to configure your EG with all the EGP with all the ASs you trust to advertise reachable IPs to you. To advertise reachable IPs to you. Oh, what? Advertise reachable IPs to you. Yeah, I get it. So that's it. So basically, it's enough to have a need for it. So 2 different ISPs. And you don't want to be an ISP. You don't have to be an ISP. RIPE explicitly says request. Oh wow, folks, we can request one. To request an AN number, we'll need to have a contractual agreement with RIPE NCC. To do this, you will either need to become a member or find a sponsoring LIR who will submit the request on your behalf. In case you represent a lot of members and you would like to automate the request process, you can use the Resource Request API. We evaluate requests according to RIPE policies and RIPE NCC procedures. We also check against the EU sanctions list. And if your organization is found to be under sanction, the resource will not be approved. Also, how do these companies work without it? Is this a public service? Is RIPE also the person, the entity giving out IP addresses? Giving IP addresses. Yes, but with an important decision. RIPE NCC is a regional internet registry. It is responsible for distributed system numbers, primarily IPv4, IPv6 addresses in the space and autonomous systems within its region. Okay, RIPE NCC is for Europe. Okay. Aaron, IP, Nick. Okay, Asia Pacific, Caribbean, Latin America, Caribbean, well, damn, Africa. Europe, Middle East, and parts of Central Africa. Okay. Large allocation. Oh, pretty damn complex, no? All these numbers need to be given in order to route everything. But it makes sense. You know, it's kind of like your address, right? The address, when you have something, you have a number on the street, you have a street name, you then have a postal code, you have a city, which arguably is kind of the same thing as the postcode, which can be deduced from the postcode, but just as an avoidance of doubt. And then you have the country as kind of the last validator until we get multi-planet. Then that's gonna be harder. But in all seriousness, this makes sense, no? It's kind of like shipping a package to someone. It's the same mechanics that are happening. From its own addresses, space. ISP your connection. Okay. RIPE NCC are in the same thing. RIPE is a broader connectivity. RIPE NCC is the organization that provides the registry and related service for the region. Okay, makes sense. So you can request one here. If you want one, you can request one. It's all good. Hey, thank you very much for the follow here. We got 556167 joining us. Welcome. Thank you very much for the follow. I appreciate it. Yay! And we reached our goal of 310. Wow, we reached below 300. Excuse me, above 300 followers. Really cool. Really, really cool. So thank you for joining us. I'm going to call you 67 because these are your last digits. What is an autonomous system? Okay, this we understand, no? Now we kind of gotta understand what it is, an autonomous system. Right? It's if you have a particular need, you can communicate within that. So now, let's move on to a lower one within the internal gateway protocol, which is this right here. All right, let me show you again. We have distance vector, and we have link state. And here we have below a bunch of stuff, which I don't understand. So let's get to it. Let's understand what these two things do. Dude, I'm gonna arrive at work. I'm gonna be so tired from having to learn all this. This is complex stuff, huh? This is complex stuff. It's not the easy peasy, oh, it's easy thing. It's the wow, it's hard. I want to go to bed hard. Do you also get this? When sometimes things get hard, you get tired? Like your bed is saying, come back to me. So here we have internal gateway protocol. 6.7. Nice. Nice. Alright, so here we go. We have a list of them. OSPF. IS. Oh yeah, you see here we have link state routing protocol. Perfect, it's explained to us. Ah shoot, what was the... I need to ask something to someone. Oh, there was a cool... Oh, we can look in our history. Alright, don't look at my history. Alright, I'm gonna look at my history. There was a really cool... what's it called? Website for finding different things. I liked it very much. I need to save it. Someone shared it on my chat yesterday. Link state routing protocols have a broad perspective of the network instead of working with the state of the neighbor's routers. Like distance vectors routing protocols. To keep track of the state of the entire network. The routers using link state based protocols have 3 tables. Alright, one more time. Link state routing protocols have a broad perspective of the network instead of working with the state of the neighbor's routers, like distance vectors routing protocols, to keep track of the state of the entire network. To keep track of the entire network, the routers using the link state-based protocols have 3 tables. They have a route table, a topology map, and a neighbors table, sometimes referred as the adjacent table. It keeps the data and routing details about directly connected neighbors of a given router. Okay, so let's do this. Let's do this, folks. Hang on tight to your seat because we're about to fly. Where's the middle of my notebook? Right here. So, link state. Link state to keep track of the entire network, the routers using link state based protocols have 3 tables. Route table, keep track of state of entire network. We have to get the route table. What does a route table do? Defines network traffic. Okay. Defines traffic rules. Okay, that's pretty clear forward. That's pretty straightforward, no? And if a given router. Okay. Topology map. Okay, so this doesn't mean much to me. Topologic. Maybe it was going to be explained later. Topology map. Actually, no jic. Map. And a neighboring table. Sometimes servers has a JSON table. It keeps data and routing details about directly connected neighbors of a given router. So it contains your neighbors. That's pretty cool. Good morning, Doc. Good morning, Hades. Good to see you. Sorry I missed your chat. Good. Good morning to you. Yeah, the routing table is how all routing decisions are made. Routing protocols make changes to the table, but aren't involved in the actual decisions. Good to see you. Nice. Nice. But you're involved in the actual routing decisions. We're learning about networks, Hades. We have the CISSP exam coming in soon. And so, as part of this, we have to understand networks. And to be honest, networks beyond just an exam is pretty essential to cybersecurity. And so we're learning about it. And so within these networks, we're looking at routing protocols, which is basically how you choose the right path to get to a destination on the internet. That's pretty much all it is. And you have two kind of protocols to get on the internet. You have the ones that are within your autonomous system and the ones that are external to your autonomous system. And autonomous systems are basically large networks. So it might be within a company, it might be an internet service provider, it might be different things. But the idea is routing protocols are basically deciding how things get from me to you and you to me. It goes both ways. So, and you have two ways of doing it. You have link state for the internal part. You have two ways of doing it. Link state and vector state. Now, we'll just learn about link state, which does it a certain way, but I'm not sure how the other one will do it different. Okay, so there's plenty of explanations here. Holy moly. Okay, so there's distance-based as well. Let's read about distance-based real quick to have an understanding. Networking is a tedious topic to study, for sure. For sure. Let me just make sure I understand the word tedious. Tedious is like a hard, I think it goes together. Tedious, define. Means boring, slow, or tiring because it takes too long or happens over and over again. Yeah, it is tiring for sure. I want to go back to bed. We were just talking about that actually before. So routing protocols make changes to the route table but aren't involved in the actual routing decisions. So who really makes the decisions, you think? Epistemic. All right, so we have we said there was two different types of there was two types of protocols in routing. Now there was we just saw the link state. Now let's have a look at distance vector. Before that, let's see epistemic comment, which says individual routers make decisions based on their route table. Okay, and so these protocols that we're seeing is basically how these tables that are used for making decisions are created, modified, and things like this. Alright, so let's look at distance vector. Distance vector based dynamic routing considers the best path between two entities communicating with each other is the shortest one. Okay. Distance vector finds the shortest communication path. I don't know, whenever I sense networking, I am here. I am in the middle of an exam. No way, Ghost. And Ghost is a network engineer, folks. Ghost is a network engineer, so good to have him on board. Epistemic said, what I mean is when a router has to make an actual routing decision where a packet has to go, it isn't using a routing protocol, just a route table. I see what you mean. It makes sense to me a little bit. Just a routing table. It goes like, oh, routing table, and it executes. And the routing table is updated by these protocols, is what we're saying. Yeah, as you said, the routing protocol manages the table. Okay, nice, perfect. Whenever you sense networking, you're here. Man, that's great. That is pretty great because we need you the most for networking. Because that's what you're good at, and that's probably what we're worst at. I'd say networking is the main area of cyber that I'm not very good at. All right. The best path between two entities communicating with each other is the shortest one. In this case, the distance does not represent physical distance, but hops. Typically, a hop is in short a device that processes a network traffic before it reaches its destination. So basically, if you had to compare it to flights, it's basically the flights that has the least layovers, but fuck whatever distance. Fuck the distance. So if I have a path that goes, I want to go from Paris to London, and there's a path that will do it with, well, Paris is, London is pretty. If you have something like Mulhouse, which is a small city in France, to what's a small city in Wales? A small city in Wales, and the one path, the one hop path is through South Africa, in Hades's basement, then probably that will be a path that the computer will consider because it only has one hop. Does that make sense? Epistemic Ghost? Yeah, as you said, the routing protocol is what manages that routing table. Okay. Give me time, I'll just wrap up my exam and return. Okay. There's no escaping my basement. Holy shit. Hades. Hades being nice and dark. My friends, the shortest communication path usually with maybe if the router detects that the delay is too long, if it finds a hop, maybe modern routers do that. If I found a router that goes to South Africa and then returns, maybe it will be like, yo, this one hop is pretty damn long, let me try another connection. Maybe. How many are there? Jesus, come count. This is making me uncomfortable. However, it is relevant to highlight that we can use other metrics to measure. Finish your exam, Ghost. getting distracted by this. However, it is relevant to highlight that we can use other metrics to measure distance and determine the shortest routing path, just as delay. Okay, so delay is also another one. A distance vector router communicates and evaluates path only between them and their immediate neighbors. Only between them and their immediate networks. So routers share their information about the network with their neighbors, enabling them to calculate the distance between them and a particular destination. Let's consider that the distance metric is hops, and there is a packet in router 1 that must reach server S as accepted next. So R1, R2, R3, R4. So obviously if you want to go to R5, you want to server S, you want to take router 4, not router 2, 3, because they're a little bit longer. Home labbing, nice. Yeah, airline analogy sort of makes sense, but the key is what considered about path. The key is what is considered about path. Okay, I see what you mean there. With a hop-based routing strategy, R1 will choose the path through the router R4, since it will result in 2 hops until the packet reaches the destination. Sadly, RAM and SSDs are a lot more difficult to acquire. On the other hand, if router R1 selected R2, it would result in 3 hops until the package reaches the destination, which is not best option in such scenario. A problem related to distance vector-based routing is that updating routing tables is a slow process. So bad news typically takes a long time to reach some routers, and the convergence time to a routing protocol project and an updated routing table is long. Furthermore, there are loop-sensitive protocols. What the fuck are those? Loop-sensitive protocols. Whatever. Not for today. The most popular distance vector-based protocol is the Routing Information Protocol. RIP. In summary, it defines a periodic table time for a router to update its table. Broadcasting V1 or multicasting V2, the updated to its neighbors. The RIP protocol defines a series of timers to control a router's lifecycle, update, invalidation, hold down, and flush. Okay, so basically distance vectors just keep track of their neighbors, and RIP, meaning Routing Information Protocol, routing, right? Yeah. Information protocol keeps table up to date. Nice. Makes sense, no? I think so. Routing base. Okay, cool. Okay, what do we learn here, folks? Honestly, I still don't understand too much the difference between link state and vector state and distance vector. Ooh, using the Bell-Ford algorithm. This is something I've seen before. This is definitely something I've seen before for the CISSP. I'm getting hungry, folks. Link states consider the whole path. Airlines evaluate all the flights along the path to the destination. Distance vectors is just considers the next hop. Is it the other way around? Link state considers the whole path. Airline evaluates all the flights along the path and destination. Distance vector just considers next hop. Airline knows Paris has flight to destination, and there's a flight to Paris, so puts you on that. Paris sorts out the next hop, okay. I see. Airline knows Paris has flights to destination, so it puts you on that, and Paris sorts the next hop, etc. And Paris knows that New York has flights in the next direction, so it takes you there. But how would Paris know that? How would... So you kind of have to have an idea of where every destination is, no? You need to know where every destination is and who probably has access to that. Folks, I need to eat. I'm gonna make myself a quick sandwich. It's not gonna take long. It's like a Polish sandwich. It's got cheese and ham. It's usually one-sided, so I'll make it real quick and I'll be right back, because otherwise I'm gonna get hangry, and you don't want that. Trust me. So good. Hungry dog means dog no learn. Exactly. And dog becomes aggressive. Alright, nice. Did you know that the country, well, the second country that eats the most pork is Poland? Thank you very much, Hades. The country that eats the most pork is Poland, and the only country that takes it over is Hong Kong. Countries by pork consumption per capita. What? I guess it differs from source. Hong Kong, Poland. Would the Croatia start eating a lot more? I thought it was Poland. I guess it might be Spain. Surprises me, huh? Because Spain, you have a bit more diversity, I think, than in Poland in terms of meats. Surprises me a bit. Like, yes, we eat jamon, like the ham. Oh, you don't eat a ton in South Africa. Yeah, meat consumption is not very high in Africa. It's pretty expensive. Yeah, and these are Muslim countries, so yeah. Yeah, these are Muslim countries, so yeah, not cool. Angola a bit more. South Africa, not much. Do you know why do you know that? There's a platform called Jetpunk. Muslim majority cities, you see here. This quiz time, it's really fun. Then you get to learn about random stuff. What would you like to do? Countries with the most territory above 500 meters. The stats won't tell the truth. A large percentage of the population won't be able to afford a lot of meat. Yeah, stats always lie. Like, averages always lie. I agree with you. It's not because the average is low that necessarily the population is quite little. Maybe there's a lot of people that eat a lot of it, but they make a small portion of it. But those who can't afford it do eat a lot of meat. Yeah, classic. And I think South Africa is one of the most unequal countries in the world. So yeah, what you're saying here makes sense. The Bellman-Ford algorithm finds the shortest path from single start to all other nodes in weighted graph. That sounds interesting. Setup. Give the start node a distance of 0. Give all other nodes a distance of infinity. That sounds practical. Look at every edge. UV. So this is a vector, I think, no? Look at the very edge. UV with weight W. If the distance to U plus W is less than the distance to V, update the distance to V. Repeat. Do this relaxations step V minus 1 times for all edges. Check cycles. Run one more checks on all edges. If any distance still gets smaller, negative cycle repeats. Exists. So that bell thingy I'm running low on space on my notebook. So uses the Bell-Ford algorithm. This is what it's about. Uses the Bell. This is not relevant unless you study for the CISSP, I think. Ford algorithm. I gotta go. Have a great day. Catch you next time. Thank you very much for coming in, Hades. Take care. The Bellman-Ford algorithm. The information of the routing table to define optimized path. Okay. That runs the Bell-Ford algorithm. So it's called RIP. RIP uses the Bell-Ford algorithm. That's pretty useful to know. EIGRP is a distance vector protocol that employs the diffusion update algorithm, searching for the best path based on reliability, load, bandwidth, and delays. So is it kind of an OR situation? Do you use OR these? The most popular IGP protocol are the open shortest path first, intermediate system gateway, open shortest path first, routing protocol, RIP. Okay, I'm gonna ask ChatGPT about this. Are all these protocols an OR and in routing? Yeah, you generally just run one internal routing protocol, so you just choose one. They're OR, not AND. You know, this is what you're saying as well. You generally just run one. Autonomous would use one IGPN. Open first, IS, ISR, RIP. Why are there multiple choices? There are different ways of solving the same problem. How should the routers inside the AS figure out the best path to networks outside my AS? Wait, what? Is ChatGPT bullshitting us here? How should the routers inside my AS figure out the best path to other networks inside my AS? Yeah, inside my AS. I agree. Inside, yeah, makes sense. To be honest, I still didn't understand the difference between link state and dynamic states and distance vectors. Sometimes you might use multiple. In Cisco network certs, you do learn about sharing information between protocols, so it's a thing, but I don't think it's very common. It's too bad, because I think sometimes protocols might be better in some situations and better in others. The easiest way to understand this is to stop thinking about the algorithm initially. Think about what the routers are actually doing. Imagine 5 cities connected by roads. Every city is a router. The roads are the network links. The question is, how does the router A figure out what is the best way to get to D? So you see, it can't get directly to B, it has to go through, to D, excuse me, it has to go through B or C. There are two fundamental different approaches. The distance vector is ask my neighbor. I like that. Ask my neighbor. All right, low on ink. I'm not sure what's happening here. Method. This is kind of the small city way of doing things. Just ask your neighbor for things. What do you know about getting to D? Suppose we have A, B, D. A might learn. B says D is 1 hop away, so A thinks, okay, D is 2 hops away through B. Another neighbor might tell A, C says D is 1 hop away, then says D is also 1 hop away, 2 hops away through C. The router is essentially learning from its neighbor routers, and that's the vector idea. A router receives information like destination D, distance 3. Okay. RIP is the classic example. What? Yeah, okay, yeah, makes sense. Because I thought that RIP was a link state, but no, it's not. RIP is a classic example. RIP uses hop count as a metric. So ABD to hop, while A through C through E through F through D is 4 hops. RIP will choose a 2 hop route. Yep. Link state, give me the map. So it says, give me the map. A link state router takes a fundamentally different approach. Instead of merely asking how far away is D, routers distribute information about their links. Routers distribute information about their links. Each router effectively learns, I am connected to B. B is connected to D. C is connected to D. Now the router can construct something like this. It maps to topology. Ooh. So one is more on runtime, and the other one is more on distance deciding on route on road deciding on execution. Of a path. Does that make sense? Is distance deciding on distance vector deciding execution deciding on a path while that path is requested, and link state keeps a track record before a request. Is that how it works? Sometimes you might use multiple. Okay, so this we've already been. You're very close, but there's one important correction. Neither one normally waits until a packet is requested to calculate the route. Routing protocols generally build update information before a user packet needs the route. The difference is what information the router uses to build its routing table. A distance vector. A router maintains a routing table based on information it receives from its neighbors. Okay, so this we've already seen. And link states goes further. They maintain a topology database describing the network. And their costs. What does that mean? What is their costs? What do you mean by cost? Be concise. What do you mean their costs? Do you pay tolls? A cost is a number representing a desirable and network direct link is ooh. The router chooses ABD because the total cost is lower. The exact mean cost depending on the routing protocol. In OSPF, for example, cost is primarily based on link bandwidth. Maintains a topology database describing the network. Folks, I hope you're hanging on for dear life here. It's pretty damn complex, but I think pretty fun as well. Not quite. Distance vector calculates the path when the request comes in. Link states keeps a record before the request. Both calculate and maintain routes before packets need them. The difference is distance vector. My neighbor tells me what routes they know about. They maintain a map and calculate the route from that map. Okay. Both protocols do react to changes. Suppose a link breaks. The routing protocol detects distributed change and recalculates the affected route. I want to learn about OSPF. I want to learn about OSPF here. So I'm just going to ask it here. One more thing before we move on to OSPF is link state then overall better? Generally for modern large networks, yes. Link state is usually preferred. Why? Better scalability. Better convergence when topology changes. Routers have a network topology map. More sophisticated back selection. That's why OSPF and ISIS are widely used. But it's not universally better. Distance vector can be simpler and perfectly adequate for small or specialized network. For CISSP, you want to learn link state is generally more scalable, sophisticated, and generally simpler. Link state routers are also more dependent on computing resources, right? Because my idea is that because it stores more stuff, require more CPU, memory, and bandwidth than basic vector-based protocols. Why? Because they need to maintain a topology database. So really the main difference then is this topology map. The main difference here is this topology map that enables more depth of knowledge retained, have less information to maintain and process. So the trade-off is roughly fewer resources, simpler but less scalable. Makes sense, no? Link state is better scalability but uses more resources. Distance vector is simpler, less scalable, but also uses fewer resources. That's could be a nice trade-off. So maybe if you're transitioning from a small company to a large company, you also want to change that that routing protocol. Nice. Got some pretty good knowledge out of this, no? Uses less resources, more scalable, and better performance. Cool. Let's learn about OSPF, folks. It seems to be pretty damn cool, and ISIS. OSPF is a link state routing protocol that uses the Dijkstra algorithm. Okay. OSPF uses Dijkstra. Where is this guy from? To find the best routes based on bandwidth and other cost metrics. Based on bandwidth and other cost metrics. I want to learn about it. I want to learn who this guy was. Yeah, distance vector is largely historical. RIP is an older protocol that isn't used much. See what you mean. Nowadays that we have the resources and all, it's easier to just keep track of everything. Finds the shortest path between a starting node and all other nodes in a graph with non-negative edge weights. Non-negative edge weights uses a greedy approach by repeatedly picking the closest unvisited node, updating neighbor distances and making nodes as visited until completion. Select the start distance, gives n a 0, give all the other nodes a distance of infinity. Hey, that's kind of similar to the is this algorithm an evolution of the what was the other one? Man, my notes are a little bit messy now. Of the, what is the one? Something Hall or something. What is the other one that we saw? The Bell-Ford algorithm. Notice that it's not an evolution of the Belfort algorithm, as both were developed independently around the same time and use fundamentally different core strategies. Core paradigm. Most users on core agree that Jigsaw algorithm uses a greedy approach by always picking the closest unvisited node, whereas Bellman-Ford uses a dynamic programming by relaxing all edges repeatedly. Honestly, I don't care enough about that. RP is an older protocol that isn't used much. GSA's algorithm is faster with a priority queue, while Belfort Man is slower. History. Published the algorithm in 1959. And Richard Bellman and Lester Ford Jr. published theirs slightly earlier, meaning GSCA solved the problem independently rather than building on their work. I want to understand who this guy was from. Oh wow, that beard. That name, oh, is Dutch. From Rotterdam to Newman. Bro is probably a math genius. No, you have to be you're a mathematician, no? At this point. Informatica tegoročná. Bardziej praktyczną. Dutch scientist and pioneer of Informatiki, of computer science. He dealt with theoretical, but also computer practical. I mean, at some point, computing kind of becomes a subcategory of math, no? And when you get down to the nitty-gritty of it, computing is just math. Do you folks agree on this? When you become an algorithm person, you're pretty damn close to using math. For examples, the OSPF runs on the network layer and ISIS runs on the data link layer. Okay. Okay, here it is. Find the best path and other cost metric. Okay. To find the best path based on bandwidth and other cost factors. And ISLS is a variant of this algorithm for routing traffic. Uses layer 3 ISIS uses level 2. Jika is a very famous computer programmer. He did a lot of early algorithm development. Jigstra. Hey, Epistemic, what's your background? You seem very knowledgeable in computer science, networks, and stuff like this. It's really cool. A link state protocol that employs a variant of GSA in the physical part. Okay. Doesn't go as much into the periodic. It is triggered. Huh, link state is triggered. Okay. Based on link states. Based on routing tables. I'm gonna ask this about this triggered aspect. Apparently, link state and distance vectors trigger differently, trigger their updates differently. One uses uses periodic changes and the other uses triggered. Tell me about this triggered aspect. What is a JavaScript? JavaScript is used for Piano asking a good question. JavaScript is used for websites, I think. No, for web applications. For making the context more interactive. Does that make sense? If you need to fill in a form and stuff like this, I think it's run on JavaScript. That's what it all means. It's a bit better with me. Alright, that's what it means. Piano. Epistemic Anarchist is telling us lots of different computing and network stuff, not usually deep in a lot of areas, but basic knowledge across it. Nice. So are you a CISSP holder as well? Nowadays I do programming, mostly data science based, but there's been a lot of sysadmin and done network admin stuff. Nice. So yeah, you know your stuff. Yes, triggered updates means don't wait for the next schedule update. Send an update immediately when something important changes. Example, A, B, and C. Suppose B and C link fails with a periodic table approach. B might wait until its next schedule update to tell its neighbor, hey, my route to C has changed. With a triggered update, B immediately sends information. BC just failed to update your routing information. Okay. Why is triggering useful? I think it makes it more important. Don't associate this with simplicity. Don't associate this as simply, it's more nuanced. So how is the detection of these changes done? Usually the router detects a change to its interface link state through messages from neighboring routers. For example, router A through router B. If the physical link between them goes down, router A's interface detects link down. Routing information is now stale. It can immediately generate an update. Common ways changes are detected. Physical interface failure. Ethernet link goes down. Fiber is cut. Interface stops responding. Yeah, just shit happens. Routing information is now stale. It can go immediately generate an update. So something is weird. It's like what the router detects as something is odd. Not CISSP, no. Done the CCNA and studied CCNP content in uni, but no exam. The basic and more advanced of Cisco networking certs. Yeah. The CCNA is probably the most famous one, no? And why is Cisco so dominant in terms of certification? Associate and the NP is higher, no? Professional. CCNA, I hear a lot about it. I think it's pretty important in terms of network certifications. It's pretty legit. It gives you a bit of that sweet that sweet street creds that we all live for in cybersecurity. Working tables, route tables, topology map, and neighbors table. Based on all the routers working in a network. A distance vector and a link state. First, we build briefly the review table prior to pressing. I like this table there. I just want to understand what ISS is. ISIS. ISIS. ISIS, let's go on Wikipedia. ISIS is Intermediate System to Intermediate System, is a link state interior gateway protocol typically deployed within a single autonomous system and is used in large enterprises and service providers networks to exchange routing information. The ISIS protocol is defined in ISO IEC from 2002. Holy moly, hasn't been updated since. Yeah, CCNA is more common. Good Basic Networking Certs covers all the basic IGP stuff. CCNP does more advanced IGP and basic EGP. Nice. Nice. So, how cool, like, it's pretty damn important to understand IGP and EGP when you do networking, you know? They're like cornerstones of networking. They're fundamental pillars. Think Cisco most popular as it's more accessible than alternatives. Juniper has their own certs, but thinks it's more expensive, so less common. Yeah, certifications can get quite expensive for some reason. As an international standard with the Open Systems Internet Connection OSI reference model. Okay. ISIS operates by flooding link state information through a network of routers. Each ISIS router builds its own link state database, LSDB. I've seen LSDB before. Link state database. I need to understand what is LSDB. What is an LSDB? Link state database is basically a router's map of the entire network topology. Link state database. Link state database. Goddamn, we're learning a ton here, folks. I hope you hung on to this stream and you paid attention. This way you'll become an actual genius. This stream makes you a genius. That'd be a nice stream for tomorrow. That'd be a nice title for tomorrow's stream. Alright, OSPF router. An OSPF router it contains information like A is connected to B, A is connected to D, B is connected to C, whatever, okay. Yeah, we saw this before. So, by collecting flooded state information of other routers like OSPF, VS, O, OS, PF. Are both interior link state protocols that use the JICA, but OSPF runs on layer 3 while AS runs directly on layer 2. How does ISIS operate on layer 2? Encapsulates routing messages directly inside because it allows a router to belong to multiple areas. What are PDUs? I feel like we've seen this before. Protocol data unit is basically the name we give data at a particular layer of the network stack. Okay, got it. Got it. It's basically how you call it. Here it's data. Data stream, segment, packet frames, bits. Nice. Okay, makes sense to me. It's sending messages at L2. There's still messages about L3 routing information. So Epistemic, if I understand you correctly, ISIS is routing level 3 by using level 2. This is a little bit mindfuck here. A little bit. Using native PDUs restricts a router to a single area boundary and detects a single designated intermediate system without backup. What the hell? Layer 2, layer 2, okay. Multi-area design. Routers can sit at area boundaries. Routers belong to a single area. Single unified process. Multi-topology. Okay, so companies will usually use OSPF and ISIS. Is more for service providers than ISPs. Okay. Yeah, it's routing as L2, I mean. It sends update messages as L3. Yeah, as L2 messages and the L3 as L3 data. God damn. God damn, folks. If you want to let me know, are you planning a deployment enterprise network or ISP backbone, or you help configuring? Okay. So it fed itself on Reddit. I've been doing some research to learn about ISIS, and I'm finding it very similar to OSPF. 14 years ago. Wow. Did the internet exist 14 years ago? Just kidding. I was already playing video games back then on the internet. That was a fun time. Is it 2012? Oh yeah, 2012. The internet definitely existed. 2012 was 14 years ago, folks. Are we talking about OSPF v2 or OSPF v3? My recommendation is BF v3 because I fixed a lot of the things that were already overlooked with OSPF v2. Curious what it does your network look like. Yeah, I read a couple of articles that OSPF can do anything IS can do, and the original limitations have been addressed. Phew. Alright. Oh, puka-chuka-chuka-choo. Good, folks. I think we learned a lot of things. We've learned a ton of things. Tomorrow, folks, we're learning about... So we stream... For those of you that don't know me, we stream every workday from 6 a.m. to 8 a.m. my time, which is midnight in New York, or something like 9 p.m. in Los Angeles and the western coast of the United States, because most of you come from the United States. And yeah, tomorrow we're back again, and we're only going to do a 1 hour stream because I have a train to catch. So yeah, tomorrow we're looking at data destruction. What you should do if you have data and you need to destroy it. If you want to join us, folks, for future times, like just share something with us, you're welcome to join us on our Discord. I'm going to show you the link. Twitch chat. Reject cookies. Always reject cookies. And Discord. Make sure to click there and join us if you'd like to do so. And yeah, folks, that was it for me. I very much enjoyed streaming with you today. Thank you very much, Epistemic, for helping us a ton. We've also had Hades in the chat chatting with us. We've also had Ghost as well with us. So it's been really nice having you all. Folks, enjoy your day, enjoy your evening, your night, and I'll see you tomorrow. Well, maybe we have someone to raid. I don't know, let me just check quickly if we have someone online. I think we only have your Cyber Doctor. The page is back, so that's really cool. Let's see real quick if there's something on Twitch that looks interesting. If not, we'll end it here. Working on scene now. Okay, let's go into software development. API wrapper. Some pretty cool. There's plenty of people actually right now streaming. Game dev. Nah, I think we'll end it here, folks. Thank you very much for today again, and yeah.